Hello, and welcome to our webinar, Artificial Intelligence in the Supply Chain, Separating the Hype from Reality. I'm your moderator, Helen King. A few things before we begin. All of the attendees are in listen-only mode, but we encourage you to use the questions panel to the right of your screen to ask questions and keep today's session interactive. We will be recording today's session, and a copy of the recording and the slides will be made available to all attendees within 24 hours of the broadcast. Now I want to introduce our panelists for today. We have Lora Cecere, founder of Supply Chain Insights, who comes to the stage with over 40 years of diverse supply chain experience. Frederick Leo is the president and CEO of Aera Technology. Fred is an entrepreneur at heart. He founded his first company at the age of 23, and prior to Aera, he was the CEO of Anaplan, which he grew from 20 to 650 employees, and over $1 billion valuation. Before that, he held several executive positions at SAP, Business Objects, and ALG Software. Kushal Dave is responsible for product management at Aera's Cognitive Solutions Development. A veteran of Anaplan and Steel Wedge Software, Kushal has over a decade of experience in enterprise software, including advanced planning systems, ERP, CRM, and analytics. Welcome, everyone, and thank you for joining us today.
Hey, thank you so much, Helen. And Fred, this is a fun time for what you're doing. I can't wait to share with the audience today. We've got over 100 people live, and we had over 400 people that signed up that will be getting this. So congratulations on entering this new space, and let's get to it. Let's separate hype from reality. How about it?
That sounds like a good plan. Good morning, Laura.
Good morning. So, when people talk about building the autonomous supply chain, we're talking about building a spectrum of capabilities from the predictive analytics that we had in traditional advanced planning to text mining and pattern recognition that we see in things like sentiment analysis or some of the machine learning that we're starting to see in master data management, and cognitive computing, which brings in rules-based ontologies, which allow learning and sensing, to the autonomous supply chain, which is dependent upon not only learning and sensing, but the use of smart sensors, and then moving that into processes, which one of the things that excites me is multi-tier processes, which we're starting to work on in our network of networks work. So today's supply chains don't sense, they respond. And often they respond based upon historic or latent data. And the evolution of decision support or rules for the supply chain are often on this data which has latency. It's not current, and it's often batch, and it's not based upon real-time sensing. So this whole evolution of artificial intelligence, building the autonomous supply chain, I find very exciting. I find that we're about 5 years away from the redefinition of decision support tools that we call things like revenue management or supplier management or rules and warehouse management or transportation planning or advanced planning, which is demand and supply and factory planning. So the impact of this is pervasive. Now, the biggest barrier to being able to separate hype from reality, I think, is our current mindset. We currently are very set in a paradigm of the advanced planning world where we have fixed hierarchies. We have to decide on the fixed hierarchies before we implement the solutions. And we feel like we've got to touch the data a lot to make it better. And in fact, one of the things that has happened, even though over 90% of companies have advanced planning tools, is we have this creation of what I call fondly Excel ghettos, where people work on Excel spreadsheets to make the data better. Then the evolution of cognitive computing and the building of rules-based ontologies and sense and learn, we have glass boxes which allow us to interact with the engines and to be able to fine-tune outputs. However, we must move past Excel spreadsheets and the belief that when we touch data, we make it better. And that's part of the paradigm that needs to shift as we go from the first generation of decision support tools to this new generation of decision support tools, because it gets at a fundamental question of the talent we need to have to manage planning processes. And as we implement new planning processes, we'll find that we need fewer people and we need different skill sets and we need leaders that believe in the power of new engines. And it isn't just touching data. Instead, it's about letting the engines do the heavy lifting based upon sensors and real-time data. Now, this evolution, as we think about it, and Helen, if we can move to the next slide, is going to be pervasive. It's going to redefine supply chain planning. It's going to allow us to build outside-in processes based upon market insights. It's going to redefine master data management because we will no longer have to hand code and hard code data. Instead, we'll crawl across data sets and the data will tell us the context of the data. It allows us to drive rule definition and redefinition of the supply chain, things like available to promise, allocation, inventory matching, rules tendering for transportation. These are all rules in the supply chain that were set up for single ifs to single thens. And as we think about many ifs to many thens with learning engines that allow the rules to be smart, it will redefine the rule sets. It will also allow sensing and the use of machine to machine automation and things like digital manufacturing as we take streaming data from factory machines to wearables to cognitive computing that will tell us when maintenance needs to happen or will redefine production scheduling based upon digital manufacturing concepts. And it'll also help us to be able to test and learn and do in vitro testing of markets so that we no longer have to do test markets with limited latency for read, but we can test and learn on individual assortment in markets based upon what's happening today. So the use cases can go on, and for more information, you can reference my blog, but this is where we're actually doing a lot of work. Right now, we see that most of the cognitive computing work is happening in either projects, so a special project, or in the redefinition of engines within existing systems. So thinking about redefining the engine within SAP APO DP, or redefining the demand engine in JDA for demand planning. And so we're not to the point where we are redefining systems, but looking at engines and rule sets and projects right now. Helen, if we move on. So the use cases are many, and as we think about the movement from traditional thinking that was inside out, which was very focused on orders and shipments, to being able to be outside in, to look at channel data, market drivers, to be able to look at multi-tier channel behavior, and to look at how do we translate what's happening in the channel with zero latency through sensing and cognitive engines. The focus on organizations within functions versus the ability to look at source, make, and deliver together, not just for an enterprise, but for a network, to be able to build multi-tier capabilities and to be able to use all forms of the data, not just structured data and batch processes, but the ability to use data that moves at multiple speeds. So Internet of Things data moves real time, pictures are more batch, and the ability to move data that comes in at different speeds into cognitive engines and use structured and unstructured data to drive output. And to also be able to embrace open source technologies like Hadoop and Apache Spark to be able to really look at schema on read versus schema on write. And the sensing to drive an intelligent response and the ability to have autonomous and localized processes that can allow us to act regionally while still connected to global parameters. The traditional thinking has been very much around functions and batch processes and latent data. As we think about the movement to artificial intelligence and cognitive, we have the ability to redefine the processes. And I think our challenge is not just to put new engines on old thinking, but to take advantage of new forms of data that moves at different speeds and drive new outcomes outside in. Next slide, Helen. So as we think about this movement to being able to be data rich and insights poor, which is where we are today, to be able to drive insights, we are moving up a continuum of analytics. And most of my clients are investing today heavily in descriptive analytics or concurrent optimization, which allow much better visualization of what's happening, but doesn't necessarily tell me what to do about it. To predictive analytics, which is more around deep optimization, it's the measurement of constraints. It's looking at multi-tier constraints and trying to maximize outcomes against constraints in predictive analytics, which many of the APS optimization engines were very much around predictive analytics. However, many of them were limited by the architectures of the 1990s and last decade. And as we move into new architectures, we are able to do much more with predictive analytics and move into prescriptive analytics, which allow us to not only get exceptions, but to tell us what to do with the exceptions, to cognitive analytics, which allow us to sense, learn, and respond. Today's engines don't learn. Today's engines are just really giving us pattern recognition off of history. So the movement from reporting to optimization to learning is a major shift, and we are the biggest barrier in this whole transformation. Next slide, Helen. So as we think about the ability to embrace new forms of analytics, when we have our annual conference, we always ask people about, analytics and what's happening and what do they believe will be the most important shifts in analytics for 2030. And you can see that cognitive reasoning and Internet of Things are rated very highly. And I think it won't just be one form of analytics. I think it will be all of the advances in analytics. And instead of hanging analytics off of traditional applications, which I call alphabet soup, in the alphabet soup world is ERP, APS, WMS, SCP. We go on and on and on with the alphabet soup. The alphabet soup was all about functional planning. What we're moving into is analytics architectures, which will sit above the alphabet soup and will connect to workforce productivity that will allow us to sense, act, and learn, and to be able to drive things much more autonomously. Next slide. So as we think about the current world, people want systems that work. 90% of people have demand management, 40% roughly think it's effective. Over 90% have S&OP, 50% think it's effective, et cetera, et cetera. No matter what the decision support is, whether it's revenue management, supplier management, demand management, sales and operations planning, there's a gap. And the gap is both ease of use and the ability to drive meaningful insights out of the engines. And I think that the new approach with cognitive and the new approach with really advancing the analytics offers a great opportunity to drive improvements. Next slide, Helen. Now, as we think about engines, we have to think about data, and we not only have to think about structured data, but unstructured data, because we're in a new world where we can use unstructured data, whether it's text or warranty data or sentiment data or images, to be able to move into engines, to be able to drive outputs. And I have demand here. It could also be supply, but we also have planning master data. And I think one of the realizations for many of my clients that have moved from regional to global planning is the need for planning master data. And planning master data allows me to see cycles and allows me to see lead times, not as constants, but as variables and as profiles. And the ability to apply machine learning and cognitive computing to the planning master data is an important concept also, because it allows me to look at what's happening and to be able to use the most current data. The inputs into the engine from planning master data are extremely critical also. And so here we have two opportunities for cognitive computing. One is the advancement of the engines. Second is the cleaning of the planning master data. And third, it is the ability to cleanse data coming in to look at things like outliers or duplication or perhaps something that is a batch file that's an issue. Next slide. The other thing is rules. If we think about single ifs to single thens, is always an issue with ATP and allocation of, how do we do things like substitution? Most of our items we can't really adequately substitute because we don't have rules that have many ifs to many thens, many customers for many options for substitution. Or how do we match inventory with orders based upon customer logic? We again have single ifs to single thens. So the ability to have an ontology in cognitive computing, which allows multiple ifs to multiple thens, is a very powerful concept for things like allocation and inventory management and transportation load tendering, and to be able to have the rules to be current based upon current data, to be able to keep track with the speed of business. Next slide. So supply chains don't play by the rules, but they could with cognitive computing. So how do you get started? Well, the first thing is you don't want to take a big brush and, say, we're going to just go all in. You want to test and learn, and you want to evolve. And you can start by redefining master data using machine learning or planning master data. You can look at planning engines and replacement of planning engines and conventional APS to basically improve the ability to drive outcomes. You can look at improving supply chain rules and build towards the redefinition of decision support. A lot of times people say, well, vendor A is going to eliminate their solution in 5 years. And I'm like, great. Let's get on with really redefining decision support to be what it couldn't be over the last decade with systems that sense, learn, and act. And that's where I think we're moving, is the ability to redefine decision support, both rules and engines, to be able to help people to have better and more informed decisions to run their business. Next slide, Helen. So, not everybody's an early adopter. In 2006, when I worked for another analyst company, we had an even bell curve. We had a more normal distribution of early adopters. Today, we have 14% of companies that are really early adopters and 35% which are laggards. If you're an early adopter, now is the time for you to be thinking about testing and learning with the new forms of engines and the new forms of rules and master data to really work together with best of breed providers to be able to redefine decision support. If you're a laggard and you want to wait and let other people pave the path, you should stay in touch with these technologies because they're moving very, very fast and they're very promising. Next slide. So in this process, one of my clients says, the first thing he needed to do was have a talk with the CFO. And in the talk with the CFO, you remove the handcuffs and you basically say, we don't know what this is going to do, but we think it's going to have immense ROI. So take the handcuffs off. Don't ask me to give you a defined ROI. And let's implement a stage gate process for a new process innovation like product innovation and have sign-offs before we roll out the new technologies to be able to test and learn. And let's embrace small, scrappy teams. Let's embrace the teams that are going to do this as people that are innovators from IT, people that know the business, but this is not a big bus technology project that involves a lot of consultants. In fact, I find the consultants are actually laggards pushing more conventional ERP-based decision support. The best sources of, information and startup help are really best of breed providers like Aera and others that are working in the space. There are about 10 cognitive computing technology companies like Aera that I would encourage people to test and learn and to have small, scrappy teams and partner with the technology innovators closely and manage the hype cycle. So, one of the things that you don't want to do is overhype this technology. You want to say it's new, it's promising, you don't know what the ROI is, but you want to test and learn because it makes sense. Next slide. So have the talk with the CFO, understand the limitations of today's technologies, start with a goal in mind, and partner with a best of breed provider. And with that, Fred, I want to turn it over to you and have you tell us a little bit about what you're doing at Aera and, what's hype versus reality from your point of view. I know you've been in the analytics space a long time. What's real and what's hype and what do you think people should do?
Yeah, thank you, Laura. I think you're 20 something years working on the periphery of the ERP world, on being an actor, with multiple solutions on what we've called this transactional automation phase, which started almost 40 years ago. If you think about SAP birth date, I think it's 1972 or something like that, or 6 maybe. But the point is, we've spent 40 years as an industry working on transaction automation and building all the different planning and analytic solutions that complement the ERP. And I feel that with the team here at Aera that we are at a different phase. Sorry, is there a technical issue? No, good. Okay. We're now at the dawn of a new phase here that we call cognitive automation. And what we mean by that is the ability to, and you touch on a lot of those topics, is the ability to automate how it requires, a lot of technology. And your questions around hype versus reality, I think you need to get back to what enables that cognitive automation. And fundamentally, the core enabler is 2012. The internet leaders, the Google, the Yahoos, the LinkedIns of the world made a lot of their technology open source and brought to the enterprise where the ability to really scale. And what I mean by that is combine transaction data with quite significant model complexity, all of that with real-time collaboration. And if I look back in my 20 years of enterprise software, this is always this thing that's been very complex, is to combine real-time collaboration with modeling complexity and transaction level. And we always had to compromise on one of these dimensions. We're not anymore. So we're now moving to this era where we can have transaction level information with the complexity of the models that we need to run in order to plan, the different components of our business and our supply chain, and be able to collaborate in real time. So we call this, you call this the autonomous supply chain. We call this the self-driving. Is this the slide that's on right now? Okay, so we're using this little car analogy, and it really literally came up in our offices in Mountain View. We're just thinking about our concepts here, and we saw one of these go by. We're on the first floor, and we said, well, if you think about a self-driving car, it's equipped with this operating system, this cognitive operating system that literally learns in real time. And the characteristic of that operating systems are that it's connected outside and in. It captures all the signals from the outside world through a series of GPS, lidars, lasers, sensors, but it also is connected with anything that's happening inside the car, velocity and all the different components that helps the car operate. So connected outside and in, and it's operating in real time and always on, which is fundamental. This is why you want to trust those devices, that they're not distracted, they're operating 24/7. and they are able to massage a vast amount of data in real time, much faster than the human brain can. They're being programmed to think, and I should say here, thinking and learning. I think you touched on that in your presentation. The learning part is almost as important than the thinking part. Thinking will be based on models that we can pre-establish, but the learning will be from the experience of running the process. And the last point, of course, is autonomous. Those operating systems have the ability to take action autonomously, change lane or press on the brakes, but also based on what decisions need to be made, inform the driver and give the driver a choice. So think about that operating system, but remove the car analogy anymore and think about what if we were able to build for an enterprise environment a system that's connected outside and in, real-time and always on, thinking and autonomous. The challenge, of course, will be to feed that system with you talked about structured and unstructured data. You're absolutely right. And if you look at the world of our customers, some of the largest companies in the world, the issue is that, they have 20, 30, one of them has 128 different instances of ERPs that are the result of companies going through M&A and trying to rationalize that. And even if you think about one vendor, if it's your standard for ERP, you may have 5 different versions of the system. So you have massive amount of transactional data that's locked into those different ERP systems that needs to be brought in. That's your inside out version of the data, brought into the operating system in real time and combined with external data coming from IoT and vendors data and so on and so forth. And that's really the complexity of the model. There is a below the line, which is bringing all this data and normalizing it, harmonizing it, indexing it into a cloud environment at scale. And then there is the thinking and the learning part that comes on top of it. So that's the nut that we've cracked with our technology. And if you think about this technology, what it does from a user perspective, it understands how the supply chain actually works, how your business actually works. And it does that through a lot of processes that I'm not going to detail right now. But in a nutshell, if you think about what Google does, right? Google doesn't crawl the internet into every time you're doing a search. Google has already taken all your website and indexed it on their servers, and that's what gives them the ability to deliver the results as fast as they do. And when you click on the link, it then brings you into the outside world. And we've basically mimicked that technology by replicating, taking a picture of all your transaction data into our cloud in real time. Every time there is a batch that's closed with SAP or any other vendors, we'll bring that data into the system. We'll do a lot of work on that data. We'll index it, we'll harmonize it, we'll augment it, we'll do all that. And that will give us this real-time visibility into your business operations. And we'll give you a quick demo later, but this is a very important first step, is have this cognitive layer that really connects the different components of your supply chain in real time. The second aspect, once you've got this system, this data in a normalized cloud environment with time series, with this cognitive layer attached to it, you can start mimicking how planners will do their work. And once you understand the way they do their work, you can start automating that process and bring real-time recommendations. So think about my concept earlier of real-time and always on. Here I've got an engine or a set of engines or agents or bots, we can call them multiple ways, that are scanning my data in this cloud environment in real time and analyzing the course of how decisions can be made and making real-time recommendation. Third component is prediction. I mentioned time series, I mentioned this augmented data. We have developed a series of algorithms that allows us to run predictions, predict business outcome, which is extremely helpful in a planning world, of course. And the last component, which is really important, is the ability to act, right? If I want to close the loop between the real-time understanding of my business operations, getting recommendations on how I can optimize my supply chain with predictions, I need to be able to act, which is literally automate how the process, automate the execution of the decisions that we've made. And with that loop, we have a full agent that's supporting the planners in real time. So Koshal, if you think about how Aera operates in for some of our customers, can you walk us through some of those use cases?
Yeah, absolutely, Fred. This is a very interesting, slide because it's very similar to what you mentioned, Laura, in the beginning as a part of the use cases in this new age and new phase where people are not looking at, standard, planning and execution systems, but they're indeed looking at, data-driven cognitive applications or cognitive skills, as we call them. And, the fundamental difference between what you see here and what the industry has been traditionally doing is the fact that it digitally replicates the entire process for you. You take this supply chain map on the left hand side here as an example, or the end-to-end supply chain visibility as an example. What it essentially does is it integrates your end-to-end digital manufacturing process, to drive productivity, increase agility, and give you several other benefits from a visibility standpoint. That was traditional. But on top of it, what it really does is it is giving you a real-time digital map of your entire manufacturing operations, all the way from your supplier, to the delivery in your markets, with machine learning, with embedded machine learning algorithms that calculates and assess the impact of the manufacturing parameters, and giving you the results such as plan CTP, which is not just rule-based, but which is machine learning or AI-driven. Which completely changes how we look at the entire process from an end-to-end perspective. This is no longer a one node to one node visibility. It looks at your entire, entire supply chain, and from an holistic, standpoint, and then gives you, these variables and results and metrics, such as your safety stock, your capacity, your lead time, your ability to deliver on time. And how you can improve your service levels, fundamentally changing, how you traditionally looked at visibility or manufacturing as a from a planning standpoint or from an execution standpoint.
So lots of different use cases where the concept of understand, recommend, predicts, and act can be applied. I think one of the questions was going back to the car analogy. If you think about self-driving cars, you have 5 level of autonomy, EAV as it's being called, from no autonomy to full self-driving. So we kind of cut our own version of that, and it kind of echoes a little bit with what you were saying earlier, Laura, around the barriers, right, to adopting those technologies. I think you mentioned touching the data, which I think is a very interesting concept. So the level 0 is where we find a lot of customers. It doesn't mean that their supply chain planning and analytics is broken. It just means that they're not really very far in the journey of autonomy and self-driving. That's where we find most of our initial prospects, right? They're backward looking. You mentioned the spreadsheet hell, which is still today, which blows my mind. I mean, still something that we hear about. And the first level, if you think about, and this is not ultra rigorous, this is our view of the world, but the first level of in the journey is to get this real-time visibility into your operations, is to get to a point where when you have a question around your supply chain performance or planning, you can actually get the answer in real time. It's building that, as one of our customer calls it, the system of reference. Now, the system of records will be the ERP, but the system of reference that's used by thousands of users every day is that technology. Once you have that real-time understanding of your business operation, then you can apply the second level, which is the recommendations. So the recommendations, I want to be clear about this. I mean, there is a part where it's rules-based. We will sit down and understand how a planner actually does the job, from the analysis to the execution. But there's also a lot of machine learning that's involved in the process to automatically capture the context in which decisions are being made, the impact of the decisions, and then we learn from that over time. So there is the quality of the recommendations will increase over time as we understand how people accept the recommendations and act with them. For example, if I come to you 5 times in a row in a given context and I say, Laura, there is an opportunity to fill open orders with excess inventory, but you have to ship it from point A to point B, and every time you say yes, and I learned that you actually believe that it's the right decision, and over time I'll be able to bring more autonomy in that process, right? So the recommendations go from a suggestions to a fully automated recommendation. The prediction is the next step, which is I'm going to use the machine to actually make real-time predictions on business outcome. And that's pretty, it's what we call the data science heaven, because we're providing this data layer with time series that's fully normalized, that includes a lot of the business metrics that you actually want to predict on. And with this, we're providing all the algorithms, so we can run the predictions over time, and we can make them part of an entire process as opposed to being a side project. Then the next level, of course, level 4, is the action, which is in itself a fairly complicated piece of technology, which is the ability to operationalize your decision back into your transactional system fully autonomously. And then, of course, today where we are with our customers is we're navigating between level 1 and 2, level 1 and 3. We have a couple of pilots right now around level 4, which are truly exciting. I think the level 5, kind of separating the hype from reality, that's still hype, right? So 2 and 3, 1, of course, 2 and 3, we have a lot of customers who are using us with using Aera with a combination of those 3 levels. We have some real projects right now, very exciting, around level 4. I think it'll be years before we go to level 5, and I don't even know if level 5 is what we want to get to. But for a single company, I think level 5 will get really interesting when you think about it in terms of network, right? At that point, there'll be incredible opportunities to to be very, very performant. So if you think about one of these clients who is sorry,
hey,
yeah.
Fred, we have a couple of questions that I just want to interrupt you. I'm sorry, but
okay,
discussions really around real time, right? Is real time hype? Do we really need real time? Is near real time good enough? Because most of the decision support tools are batch, and they're not real time, right? They're planning tools, and rules are working on time horizons. So the discussion around real time has kind of spurred a lot of questions. Does cognitive have to be real time? I mean, isn't it possible that what we're doing here is just as effective and time phased, longer term processes?
So it's a super good question, and we have to we have to define what real time means. I mean, we cannot be more real time than the way the transactions are being recorded and processed, right? So if you are processing your ERP batches every 8 hours, and the data that's going to feed, that's the internal data coming into Aera, will be a few minutes after the process is done in SAP. What real time does, Laura, I think, is trust. So I think we can define real time as that what you're seeing right now on your screen is the most up-to-date version of the data. Is it true real time? It doesn't necessarily matter based on the decisions you're trying to make. Is it actually the most up-to-date data that you can get? That's the trust that you need to establish, and that concept of real time helps establish. One of the criteria that we have is with one of our customers, one of our goal, we define business real time as within 15 minutes of the event actually occurring. And what we said is we want 50% of the data in our system jointly with this customer to be within 15 minutes of the event actually occurring. To get to that point, there is a lot of work that needs to be done. So as Kaushal touched on, there is a lot of use cases that we're touching with our technology. Some of them require this real-time concept. Some of them do not. If you're looking at the long-term planning, you don't need to have real-time data. You need to know that you have the most accurate and up-to-date data. Kaushal,
Right.
do you want to add?
No, I think it goes from use case to use case, like you mentioned. That's pretty clear.
Yes, exactly. And I think it's, generalization, it can be at the speed of business, and it decreases latency, right?
Correct.
And then we have a question on how do you bring in data, and what kind of technologies are you using for the cognitive layer? And I don't know, Kushal, if you're going to touch on that, but we've got a lot of questions on that.
Yes, we'll definitely touch upon some of the elements of our data crawling technology, which is a patented technology that we have today. It is fundamentally different than your standard ETL logic because of the fact that the data crawling means that it kind of understands what every bit of that information in your transactional source system means. When Aera crawls into the your ERP tables or your CRM objects, it fundamentally understands and it knows what that piece of information means. When it brings it back into the Aera cloud, it makes it pass through the several different subject areas or facts, as we call them, which kind of allows us to build this cognitive data layer. And once it crosses the cognitive data layer, that becomes an intelligent piece of information on which you can apply data science and several other AI algorithms, so on and so forth. So it is very different than your standard standard ETL logic and data integration technologies available out there.
Yeah, step one is to crawl the data. Step two is really this understanding. We have mapped today, I think, 18,000 fields of transactional system. 18,000 fields have been I will say mapped by hand, so to speak. And this is this intimate knowledge of the source data that allows us to build this, what we call this cognitive layer, this intelligent layer, because you cannot have intelligent decisions if you don't have the context of the data. And maybe, Kushal, we can do a quick demo to illustrate that concept, Laura, if that's okay with you, because I think it'll speak for itself when we can show it.
Yeah, we've got a lot of questions around dirty data, and there's a belief that you can't really move to this direction with dirty data, and my belief is just the opposite. The dirtier the data, the more you need to move in this direction. Fred, your perspective in this?
Yeah, I think you have an interesting angle on that one, where the dirty data is never good, obviously, but the problem that we have is define dirty, and I think that's a much longer conversation. When you are blending, when you're bringing data from one of our customers right now is 128 different ERP systems, your data can be clean in every one of these systems when you start bringing together different sources. So let's just say that we've cracked that nut. I don't want to go into a long discussions. I'm happy to take that maybe offline, but it's all down to our crawler technology that goes down to the bottom of the table, so to speak, and this mapping that we've done. So the data is going to be, when you bring it into Aera, there is a preparation phase that's happening with our algorithms that actually makes it usable, because it can be clean or dirty when you're blending data coming from all the different data sources. If you don't have a technology answer in real time, it's going to be an absolute nightmare. The question we have around that is, I have already a data lake. Can I connect to my data lake as opposed to my ERP? The answer is yes. So we've got that pretty much sorted.
Right, because most of the data is not dirty, it's disparate, and
Yes.
harmonization and synchronization is key, and it isn't about integration, it's about harmonization. And I think that the more issues people have there, the more they should consider this kind of technology. I'm going to let you guys go back to your presentation and let's get to the demo, but we're continuing to get lots of questions. I've got probably 50 questions in the question panel, so a lot of dialogue.
So look, given the time, we have 15 more minutes. So I want to give a bit of time for the fun thing, which is the demo. So I'll go super quick through the slide. Okay, sorry. So we had this one slide on Merck, which is one of our pioneers, and I want to give Alessandro De Luca the credit for coming up with the self-driving supply chain analogy and helping us build and innovate. Has been one of the main driver behind a lot of our innovation. So we're very grateful. And Merck is a historical customer of Aera that's been pushing the boundaries and really pushing on the self-driving supply chain. So there's some interesting article in the Wall Street Journal. As a religion, we don't speak about our customers because what we do is pretty high level and confidential. We have this slide because Alessandro spoke about his work in the Wall Street Journal. But with that, let's move very fast to Kushal. and go into a quick demo of Aera, and then maybe we have time for a few more questions.
Yeah, absolutely, Fred. So I'm going to start with a demonstration of the Aera voice application first, which will give you a very good understanding of the concept of understand, recommend, predict, and act through the mobile application itself. And then we'll go into the web-based demo and demonstrate some more platform capabilities, followed by a very interesting use case from a supply chain standpoint. So I'm going to log into my voice application, and I'm going to ask my Aera app a bunch of different questions which are relevant to my business. Aera, what is my revenue forecast for this month?
On-track revenue forecast is $1.25 billion against a $1.2 billion target.
Which regions are below plan?
Latin America revenue for November forecast is short by $46 million. Service levels are expected to drop below 85% as a result.
What is my backlog for Latin America?
Backlog has risen by $39 million, largely due to finished goods shortage of the logo product. I've found excess inventory for the logo product in Mexico. If the excess is shipped to Brazil, an estimated $32 million of the backlog can be converted to revenue.
Please take care of that for me.
I am processing the action now. I will let you know when it is complete. Have a nice day.
So this is, a very good example of, how I could just, understand what's happening in my business, via my phone. I could, get some recommendations from Aera, through the algorithms and machine learning and AI that it's running in the backend, and then also, very nicely just take an action, which Aera just took for me. So this was one example of what I could do through my mobile application. Now let's go ahead and look at the web demo.
So you were on your phone here, on your iPhone, as we were speaking.
Yes.
You were just you fired the app, and now you're going into your browser, and same interaction, same application, but different medium.
Yep, absolutely. And as I log into the Aera application here, the first thing I see is, yes, I see the confirmation that Aera has recently assigned unrestricted stock to open order, something that I just asked Aera to do. I can also see some really good and strong recommendations or opportunities, which is telling me that if I move my stock from a factory to another factory, I could gain a sales opportunity of, $52 million. I have some descriptive analytics also listed here in terms of, what's my expected revenue. Somebody has shared a report with me, and, I have a customer which has triggered an OTIF exception. What I see here on the top is a Google-like search bar. This is also a game-changing view for anybody, who's using Aera today, because it gives you search results which are contextualized, which are personalized, and they're also connected in a certain degree, right? So if I do a search for this customer, which has triggered an exception here for an OTIF exception, it'll give me results that I really need to see on a day-to-day basis. So let me just search for this customer. It gives me several different suggestions, and I'm going to look at the one that has triggered that exception. And the first thing I see here is, of course, I see that customer name, but I also see, the metrics that matter for that particular customer. This is a completely customized view that I'm seeing here. The viewlets that I see here, these bar charts, are, the contextualized version of what I just mentioned. There is, strong context behind this customer and what I want to see, and it's completely personalized for my use. Here, what I see on the right-hand side is a knowledge graph, which is, a suggestion of all the important related information that the user needs to know. From this customer standpoint, you can see that it's connected to the relevant vendor, to the relevant distribution center, to the relevant plant, and to the relevant raw material that, also this customer needs to be, connected to from a supply chain standpoint. I can also see similar customer results, as well, which is using something, similar to a market basket, architecture that you would see in, financial institutions or, retail institutions as well. So this is, the search results are also, algorithmic in nature. There is data science behind it, and, they are very powerful when it comes to, just a simple visualization, and getting some, personalized context on, what you want to see.
And Kushal, this is what we meant by the system of reference, right? This data comes and it's actually, I'm not going to have time to do it, but you could in one click go down to the transactions, and the transaction can be coming from multiple systems. So this one click gives you access to an aggregated view of the data coming from potentially 10, 20 different transactional systems, or blended with external data sources as well.
Absolutely.
So can we switch to more about a specific use case now?
Yeah, absolutely. So let's pick one that, Lora mentioned this morning, right? I mean, she talked about ATP,
Sure.
Which is fundamentally nothing but a rule-based calculation in transactional systems, or, typical, APS, APO systems. That has become kind of irrelevant because, rules are based on, theoretical lead time, theoretical allocation rules, which in reality, from a supply chain standpoint, are incredibly variable and volatile. Nothing is, constant. And, when you use those, variable elements in formulas and, back calculations, they are going to give you wrong available to promise dates or wrong, plan capable to promise dates as well. So if you look at this particular example, here's a very simple view. And again, this has a Google-like search interface, which makes it incredibly simple. All you see here is a place to enter your order number and a place to enter your order line item number. The customers that we are working with today, are asking us to crawl into 50 plus different ERP systems, enterprise data grids and enterprise data lakes, and are asking us to fetch information which is of the order of 100,000 plus orders per day, and 15 to 20 million order line items per day. And when you have this amount of massive data across multiple different ERP systems, or your CRM systems or any other systems, it becomes very powerful to get this simplistic view and do a simple search and get incredibly powerful results from it. So let's do a simple search on this. I'm going to enter a particular order number and a line item within that order number. And I'm doing a search here, which is using the same search technology that we saw in the previous example. And what it opens up is an entire supply chain map for me, a distribution map for me for that product, that is in that order line item number in that particular order from a specific ERP system. What you are seeing here is, the allocated quantity, the order quantity, the available to promise date, and the expected delivery date. Now, this is not the standard back calculated, ATP date. The first thing that you can see is, you did a search because Aera understands. You get a recommendation on an ATP date because, Aera can make that recommendation using machine learning. If I click on this particular pop-up, you can see, all the different, schedule lines for that particular line item number, but you also see a machine learning based recommended date, ATP date range, which is, very powerful recommendations from a data science perspective as well. Yes, so there is also this component of prediction, which now allows you to kind of get a more accurate date, similar to what Amazon kind of provides when you do purchase something from their site. And then you can also take an action, which I can do through my web application here, and see if I could kind of get this order a little bit sooner. So I'm going to go back into my voice application, and this time I'm going to kind of ask the same questions that I asked the Aera web application. So what is my available to promise date for order number A10001?
The locale shell. The available to promise date for this order is November 23rd, 2017.
Can I get the order sooner? Okay, I'm going to have to re-ask the question because of a glitch. What is my available to promise date for order A10001?
Hello, Cowshell. The available to promise date for this order is November 23rd, 2017.
Can I get the order sooner?
There is an opportunity to reduce the production lead time and subsequent in-transit lead time to Memphis, DC. Would you like me to send an alert to the production planner to make parameter adjustments?
Yes.
Okay, sending an alert to the planner now.
So this is a very good example of how you can also take action. So it kind of now is no longer a rule-based ATP module, but it is a cognitive skill, a cognitive ATP skill.
Kaushal, thank you. And we had to add that little glitch, of course, because otherwise it wouldn't be a live demo. Lora, I know we have just a few more minutes for questions, but we thought it would be interesting to show where the most advanced customers are. This use case that we just illustrated here is actually something that we're rolling out for one of the largest and most complex company in the world. So it's interesting to see the state of the art here. So I think to a question, hyper reality, this what we've shown is reality. Okay,
well, good. I've been answering questions as we've been going along. Is there anything that we want to wrap up here with? Any last minute thoughts?
No, look, from our perspective, it's always fun to talk about this topic. I think you asked the right questions and you made a lot of good points in your intro. Hyper reality, I think it's becoming fast and furious a reality. And I think the key is to your point about, companies who are slow to move in or have issues with their data. I think the real issue is what happens if you don't move fast toward those kind of solutions, because the power of this cognitive automation is certain.
Yeah, and we've had an awful lot of questions around dirty data and if I use these engines on top of SAP or Oracle, won't you get conflicting answers? We've had decision support tools that allow engine replacement for years, right? I think we've got to break down the barriers within ourselves to rethink our technologies. And there's a lot of questions around real time. Our processes need to move at the speed of business. ATP or transportation routing moves quicker. Most people are dealing with latency of data. Demand planning should not be a real-time process. Supply planning should not be a real-time process. But people should be able to get exceptions and resolve exceptions quicker than what they do today, and right. The system should work for them. And so as we think about the redefinitions of planning, I think we've got to get past our current paradigms to really embrace the future. So guys, thank you for this, and we will archive it and share it, and we'll also be sure you get all the questions. So if you want to answer them directly, you can. Thank you.
Looking forward to it. Thank you very much.